is with 1/3, yeah. We just don't know, or say 0.3, I think that's another one they have in the book, right?
So is there a way to solve that?
Uh,
Like, not that specific one, but if we have sine theta equals -1/3, is there a way to sign?
Yeah, I mean, you just have to leave it like this. If you want it in an exact form, then just leave it like this.
Or you put it in the calculator.
Or you could approximate it, right? And so I don't know what it is approximately.
I mean, you know,
Yeah.
I was
So
wondering.
here's -1/3 and -2/3, right? -1. So -1/3 would be here. What's the y? What's the angle that produces that value, right? So this would be the angle whose sine is -1/3, I guess, right? Clockwise, it's negative. It looks like it's hard to say.
I mean, that doesn't really, I was just wondering
No.
if like that, there was any other way to do it aside from
Yeah,
sticking the
yeah.
calculator.
Well, you know, in the old days, you'd look it up in a table.
Yeah,
Yeah.
but that's like, that's the.
But that's just kind of
the
like
form.
a calculator.
Yeah,
Yeah.
okay.
And you would just get an approximation, you wouldn't get an exact value.
But if it's one of the things that we know.
Yeah, but if it's a benchmark value like √2/2 and √3/2, then we know we can simplify like over here. Yeah, good question actually, because obviously becomes a problem. If it's not one of the benchmark values, then just leave it. If you want an exact form, just leave it as an inverse sine value. So maybe we should do another one. Okay, so 44. It's got a fourth power of tangent. So here we got a quartic function. And it's fourth, so it's 1 -1336, and it's quartic in tan theta. So tan to the fourth power of theta minus 13 tan squared theta plus 36, and that's equal to 0, I believe. So this is number 44 and 7.4. Yep. Okay, so we have 0 on the right-hand side. That's good. So we can factor. That would be swell. Do we have two numbers whose product is 36, which add up to -13? Right, that's what we learn in basic algebra when we're factoring trinomials, right? The leading coefficient of 1. So yeah, tan squared theta minus 4 and tan squared theta minus 9. Well, there's two numbers whose product is 36, which add up to -13. And so either tan theta equals ±2, or tan theta equals ±3, right? Is that too much of a jump to there? Like if you square either 2 or -2, you get +4. 4 minus 4 is 0. That makes the product 0. Same thing with 3, right? You square that, you get 9. 9 minus 9 is 0. Right? Are we done? No. We're about halfway there, though, in a way. Right? We factored and found the values of tangent. So should we dial those up on the circle? And how do you do that with tangent? That's too big.
I know.
I need a smaller circle here. That's too big. Is that too big? Why was I saying it's too big? Well, you gotta find the value of the tangent function on the tangent line, and not just any tangent line, but the tangent line here, right? Here. So I'm going to draw the line tangent to the circle there, and I'm going to say this is the unit circle. So the radius is 1, and so this is 1 here. And if I mark off another one, I get 2. If I mark off another one, I get 3. And I can do the same thing going down, right? There's -1, another one, -2, another one gives me -3. So this allows me to find my angles, right? Because I can say, well, at 2, I've got this right triangle. What do we know about the tangent of the angle in a right triangle? It's opposite. There's a right triangle, right? But that's tangent, so it makes a right angle at the radius. And so what's the ratio of opposite to adjacent? 2, right? And here it's -2. Let's see, that's going to be symmetric. Right, so I've got these two triangles where tan theta is 2 or -2, and then up here it's going to be 3. Again, ratio of it opposite to adjacent is going to be 3 to 1, right? Here. And here's going to be -3 to 1. So there are my 4 primary angles between -pi/2 and pi/2. Tangent is different than sine and cosine. Sine and cosine have a period of 2 pi. Tangent has a period of pi. Right, so instead of adding multiples of 2 pi, I'll be adding multiples of pi. And you can kind of think of angles on the other side, producing the same tangent values. Like in the second quadrant, you get the same sign as in the fourth quadrant, right? Tangent is negative. Tangent is positive in the first and third quadrants. So I basically, I don't know exact values, right? But I can say theta will have to be the inverse tangent of ±2, which since tangent is an odd function, I can say is plus or minus the inverse tangent of 2. Right. And similarly here, theta is going to be plus or minus the inverse tangent of 3. Or what? Any multiple of pi plus those, right? So, I'll tell you what, I'm going to say plus k pi here. And for the other ones, I'm going to erase this and put in plus or minus. Arctan is the same as inverse tan. Yeah, right, so what do they mean by arctan? They mean this arc subtends a central angle whose tangent is 2/1, right? So the arc whose tangent gives you 2/1 is the same as the angle whose tangent is 2. Arcs and angles are sort of interchangeable, right? I'm a unit circle anyway. Since, yeah, that's the way radians are defined. All right, so again, where k is any integer. And I think that's kind of it, right? So this is the solution. These are all solutions? Did they, I think that's what they did. Was there more instructions? Am I missing something?
It says solve.
Solve, right. Is that the only, it says, solve by factoring, solve the just solve the given equation. So that means find all solutions, right? And there are infinitely many. There are, these primary solutions, and then any multiple of pi, right? And so, to be sure, if I were to lay theta out horizontally instead of going around the circle, so here I'm thinking of theta as going around the circle. Here I'm just laying it out linearly on a line. Now what does a tangent function look like? Well, here's pi/2. Right? here's then pi is twice that, well, maybe here, right? Perfectly evenly spaced. And then, well, maybe even there, huh? So these are the same length, and another one here would be 3 pi over 2. That's another vertical tangent, right? Or asymptote. And then this would be 2 pi here. 5 pi over 2, I guess I could put in that one. And another vertical asymptote for tangent. Are you familiar, remember this function, drawn this way? So negative pi over 2 is another vertical asymptote. And here's negative pi then, negative 3 pi over 2, and so on. So all the odd multiples of pi over 2 are vertical asymptotes. And so what does a tangent function look like? This is kind of drifting over here. Straight up. So it follows the asymptote, sort of curves downwards until it gets to this point, and then curves upwards following the asymptote up, right?